Well, Algebra Geometry 3 classes, good morning, good afternoon, or good evening. We are going to start, at least briefly, into the final unit of the semester, Unit 10. And with that, it's going to cover some topics from both first semester involving factoring and also some of the properties of exponents from Unit 8. So there is some review topics that are going to show up here. And this will be something that certainly for those of you taking either Algebra 2 or Intermediate Algebra 2 next year, that will help quite a bit. So in 10.1 day 1, we're going to go over simplifying rational expressions. And a rational expression is an expression where both the numerator and denominator are polynomials. And if you remember going all the way back to Unit 1 first semester, a polynomial can be a term or sum of terms where each term is the product of a number and a variable with only whole number exponents, meaning positive numbers. 0 cannot be the denominator of a fraction. If you try to divide by 0, it's undefined. Certainly if you enter into your calculator something like, for instance, 9 divided by 0, it's going to give you some sort of an error message. So you cannot have 0 in your denominator. Any value assigned to a variable that results in a denominator 0 must be excluded from the domain of the variables. And these values are what we call excluded values. So for the first group of problems here in the notes, we are going to go over just determining what those excluded values are. And basically all you have to do for that is take whatever the denominator is, set the denominator equal to 0, and solve. So here just add the 3 over. So 3, if we were to plug that back in, would give us a denominator of 0. 3 minus 3 is 0. So our excluded value is that x cannot equal 3. For our next problem, now one of the things too that you want to make sure of is when they give you an example like b, y equals x minus 4 over x plus 1, do not worry about the numerator. That's a very common mistake because you see a variable there and you want to solve both. Just take what's in the denominator, set it equal to 0, and then solve it. Subtract the 1. So if we were to plug a negative 1 back in, negative 1 plus 1 would be 0. So our excluded value is that x cannot equal negative 1. So in theory, what we're doing with these problems, we are finding the numbers that would not work for these. Sometimes you can even have more than one excluded value. So for this one, I'm going to take x minus 6 and also x minus 9. So for the 6, I am going to have to add. For the minus 9, I'm also going to add. So for this one, we actually are going to have two excluded values. One of them is that x cannot equal 9. X can also not equal 6. So I know kind of cramped space-wise here, and so that's why I'm just kind of working where we've got some space. For the next one, 3x minus 8 over x times x plus 5. Well, again, this one's going to have two excluded values. For one of them, you actually don't have to do any work at all. For the x that's by itself, we set it equal to 0. Well, since there's nothing to solve, there is your first one. The next one, we take x plus 5, set it equal to 0. Well, for the plus 5, I am going to subtract. So the other excluded value is negative 5. So x cannot equal 0 or negative 5. All right, for the next two of these, y equals 3x over x minus 3. Well, a and e actually have the same denominator. The only thing that's different is the numerator. And you will see, because of that, their excluded values are the exact same thing. For f, x equals 0 for the 12 over x portion of it. You don't have to solve anything there. For the x plus 2, I will just subtract, and the two excluded values are 0 and -2. All right, for example G, now is where we are going to have to do a little bit more work. And this is where I was saying we're going to review over from Unit 2 with factoring. Now, whether or not you remember when we factor, this is where we are looking for what multiplies to the final term of -10, what adds to -3. Well, if you go back to your factor chart, the factors of 10 are either 2 and 5 or 1 and 10. Now, whether or not you guys remember, if it adds to a negative, we are going to make the larger number in our factor set the negative. So either 2 and -5, 1 and -10 are our factors. Well, the ones that multiply or that add to -3 will be 2 and -5. Now, from there, what's going to end up happening? We are going to write out our factors. It's going to look something like either C or D or F. So here, our two parentheses will be x plus 2, x minus 5. So these are going to be the two things that we set equal to 0. So x squared minus 3x minus 10 is x plus 2, and x minus 5. So from there, subtract. So one of our excluded values is -2. The other one, add the 5, positive 5. So here is where try and squeeze those in. So like I said, this one had a little more to it because you do sometimes have to factor your denominator out. All right, now the next thing we're going to talk about is actually simplifying rational expressions. Sometimes you have to factor numerator and denominator, then state the restrictions, and then if you have common factors in numerator and denominator, we will cancel those out. So for starters, anything that is in the denominator, so like right here we have y and z in the denominator, if there is not any addition or subtraction, we're just going to say these can't equal 0. And this one does not have an a, so we don't need to actually worry about that. Now, as far as what we are going to do here, the 14 over 8, well, first you can always divide and see if they come out evenly. Well, if we take 14 divided by 8, it's 1.75. So instead of dividing there, what we are going to do is we are going to reduce. Well, 14 and 8 both divide by 2, so that's going to be 7 over 4. Now, the other thing that we do when you are simplifying with exponents and its division, you subtract. 3 minus 2 gives us 7y, and then 1 minus 4 gives us z to the -3rd, and then your final step, because we have a negative exponent, that moves to the denominator and becomes positive. So that is your first example of simplifying. Now on example B, -12a to the second b to the second over 18a to the 5th. Well, if you notice, the only variable in the denominator to start here is a. So we're going to say from the beginning, a cannot equal 0. Now again, if you start out dividing, negative 12 divided by 18 is negative 0.6 repeating. You can either convert that to a fraction if your calculator does that, or when we reduce, well, 12 and 18 both reduce by 6. So negative 12 divided by 6, negative 2. 18 divided by 6 is 3. Now from here what we're going to do is again subtract 2 minus 5, a to the negative third. If there's nothing to subtract, you keep it as is. Now from here again we have a negative exponent, so that is going to have to move down, leave the negative 2 and the b to the second in the numerator, and then move the a to the negative third to the bottom. And when you move that down to the bottom, remember that the exponent turns positive. So a couple of other examples that will now work a lot more like what we did on the top part. So 3y minus 9 over 4y minus 12. Now, one of the things that we're going to talk about, 3y minus 9 and 4y minus 12, they both have a GCF, meaning something we can divide out of each. Well, out of the 3y minus 9, we can divide each of those by 3. So if I take 3y divided by 3, I get y. If I take minus 9 divided by 3, minus 3. 4y minus 12 here, the GCF. What can I divide out of each of these is 4. So basically what you're doing is we're kind of undistributing when you factor. Divide the 4 out of 4y, it leaves a y. Divide negative 12 by 4, it's negative 3. Now, that will allow us to find our excluded value. So y minus 3 equals 0, add the 3. So y equals 3 is our exclusion. Now, the last thing that we can do with this problem, when I have a common factor in the numerator and denominator, I can cancel those out. And our end result here is just 3 over 4. Now, for example D, we are going to have to factor both the top and the bottom. Now, for the top, when there are only two terms, we use a GCF. Now, our GCF, meaning what can we divide out of each of these in the numerator, is just x. If I divide an x out of x squared, it leaves x. If I divide x out of 3x, it leaves 3. Now, for the denominator, we are going to have to look at what multiplies to 9 and adds to 6. Well, there are two sets of numbers that multiply to 9. 1 and 9, or 3 and 3. Now, in terms of what adds to 6, 3 and 3. So what that means is this one is going to have two parentheses of x plus 3 and x plus 3. Now, because these are the same, you actually do not have to solve both of these equal to 0. We can just solve one of them. So subtract the 3 over, and our excluded value is negative 3. Now, over here, we had a y minus 3 in numerator and denominator. We were able to cancel those out. Here we have 1x plus 3 in the numerator and denominator. I am able to cancel the 1 in the numerator with one of those factors in the denominator, and then that leaves x over x plus 3. Now again, one of the more common mistakes shows up here. Do not cancel this x and this x. This x plus 3 is a quantity. In order to cancel, you have to have a full x plus 3 in numerator and denominator. So, one final example, a squared minus 2a minus 8 a squared plus 3a plus 2. We are going to now have to factor both the top and the bottom. For the top, has to multiply to negative 8, has to add to negative 2. Well, our numbers that multiply to 8 are 1 and 8, 2 and 4. Now again, if it has to add to a negative, we make the larger number negative. So our numerator will factor using 2 and negative 4, meaning a plus 2, a minus 4. Now, for our denominator, multiplies to 2, adds to 3. Well, here the nice thing, there's only one set of numbers that multiplies to 2, 1 and 2. Obviously, since there's only one option, those are our two numbers. So, our denominator will be a plus 1 and a plus 2. And we are going to be able to cancel the a plus 2, so that leaves our answer as a minus 4 over a plus 1. And then the only other thing that we'll do real quickly is take each factor and set equal to 0 for the excluded values of negative 1 and negative 2. So those are the excluded values for that. So again, this was 10.1 day 1. There will be a Schoology assignment for this, and certainly if you do have any questions as you watch through this or work through things, the live sessions will still be offered every Tuesday through Friday.